Hello, I'm Chris. This is Gross Models. Welcome to part 2 of the Inventor.io AI Apocalypse Day Zero course. Basically, that's the easy way of saying it, isn't it? Right, let's see the introduction and then we'll get to actually building some stuff.
Ah, fantastic. These Hero XLs still work and we can use them to operate the devices here at our new home. That now that the AI has been used to being in control of everything, we will take back that control. Now, even during daylight, these rooms can get pretty dark. I mean, especially without windows. Luckily, we have some, so we're able to see a little bit. I mean, the solar panels above, they seem to be producing power, and luckily it seems like they're still connected to the circuitry down here. So these offices actually already have a whole bunch of LEDs and everything like that already built into them. We need a way to control them. And since all those control panels seem to be torn up and resources seem to be taken over the years, it doesn't look like they're very usable anymore. Well, actually, here's an idea. Let's open up this kit and let's grab the LEDs out of the kit, because we might be able to use these to simulate exactly how to solve the problem.
Okay, so the parts required, apart from the board, which is always required, we need a couple of cables, a breadboard to mount the things on. We need an LED. What should we go? We may put in some lights on. I'll go for a blue one. Nice blue LED. That'd be quite pleasant. And we need a resistor. Now, the resistor is required because basically the voltage given out by the board is too high to safely run the LED on its own. You can, but it will probably burn it out quite quickly. I don't know how quickly. I've never tested it, but it's always best to make sure things are running at their correct voltages. So these are 220 ohm resistors, which I've used previously when I did the looking at the parts thing. So if I can get the one out without taking another one off the paper. There we go. Just need the one. So we've got one here. We've got an LED with a longer leg being the positive side. Getting those out just a little bit each way. So we'll get those in. Put it in there. That'd be the best bit. I'll go in there. So the what have we got? The resistor is connected to the ground rail, which is the negative one. So that one up the top there. And that goes to the negative side of this. So I'm going to turn that around the other way. So the positive on the right there keeps things a little bit neater. So one side of that goes in there, one side of that goes in there. Breadboards are connected. The top and bottom runs are horizontal this way. All of the other little ones are individual strips that go vertically just on the 5 or 6. We've got 5 pins on each of those. All those 5 are connected. Those 5 are connected, not to each other, just to themselves, and same down here. Whereas all of this is connected across the one line. So we can take the positive side of the LED there and the negative from anywhere along that ground rail. The ground one we will put into the ground pin, which is the last one down there, like so. And this one will go into 22, which is
I don't know that.
Top one up there. And that has already come on, even without the code being activated. But because we don't know what we're doing, I'm going to get the code activated anyway. So I'll copy that and paste it into there. Let me show you the code, see what we've actually got. I'll run through it in a moment, but I'm just going to upload that to the board first of all. If I select the board, obviously first, filing, done. That is now sent. So that has sent that light on. Let's have a look. It should be flashing. It's not flashing. So something is not right. Positive to the positive, 22. Right, let's troubleshoot it together, shall we? Let's have a look through here and see exactly what we need. Now, LED there. Right, so we've set up a constant saying light equals 22. That's the pin 22 where I plugged this. Is there also 22 on the other side? Let's just track that across there. I think they're both the same, but you can just got a choice of two. Okay, so that's just telling it that whenever I say light, I mean pin 22. Nice and easy. Then we're setting the pin mode. We're setting light to be an output, which it is because it's the LED. Then we've got the loop that we set up last time, saying digital right light high, wait for a second, digital right light low, wait for a second. Why is it not doing that then? As far as I can tell, that should be running. Let's upload it and make sure again that it's doing what it should do. Gone in there again. It's a very small file. It shouldn't matter. I don't know. What I am going to do is add in some more. I shall put another digital right. Which you've got to have a capital W. Make sure you get it right. And spell it right as well. Digital right. Actually, I'm going to have to go and research. I want to set up the blink that we had basically running as well. So I can make sure that that flashes and see why that doesn't. So I shall compile a code and figure it out and get that going and return and see what I can tell you. Right, after much faffing about with the code, copying, pasting and trying to copy from the last time, I've actually used the file from last time, as you can see there, with some extra lines from this one to set it up for pin 22. I found out the problem. The problem was I'm an idiot. I already knew this, but I didn't realise that just how far I'd gone. I hadn't plugged it into pin 22. I plugged it into the pin above pin 22, which is plus 5 volts. So it was basically just providing power through an LED back to ground. So hence the LED came on and stayed on. Yeah, I'm an idiot. I've changed the timings to half a second just to spice things up a little bit. And you can see now both of them flashing in sequence, well, in concert, in fact, not in sequence. They're doing it at exactly the same time as each other. Yeah, so there we have it. Always check to make sure you've got things plugged into the right ports. The reason I had trouble with is this is slightly, not so much offset, but it looks like it's offset. So the ground labelling is actually not quite next to the ground bit. It's got an arrow against it, so it does sort of say it should be there. So yeah, it's just me not reading things properly. But that now is working as intended, so that's fine. Now, obviously, if you were connecting this up, as they say in the course, to actual lights, you don't want them flashing all the time, which is why tomorrow we shall be returning to this circuit, to this board, but adding, I believe, a switch, basically, a light switch. Now, there are many different ways of doing it. You could just wire it up directly, like I did, and put a switch in to turn it on and off. But if we can get the switch to activate a thing on the board to do other things, it's learning. It's not the simplest way of doing it, but it is a way of doing it, and a way that will reinforce and teach us things about electronics and coding and listening to what switches say on the board itself rather than anything else. Now, the one thing that I should mention is although this board is plugged into the computer is not doing any of the work. The file has been uploaded to the board. All the computer is doing now is providing power to it. You could provide power to it through other means, through a power bank, or using the barrel socket there to provide power into it in other ways. Don't think that I'm doing things with the computer to make it do the flashing and controlling and stuff. It's all being done on the board. So that is that. Another day done. I shall return tomorrow, as I say. I think putting in a switch or a button to figure out how it works. So I shall. Well, I'll let them tell us about that in the course, and then I shall see you next time. So thanks for watching. Bye bye for now.
So let's quickly go up and hit upload. And we should see it's compiling the sketch. And up, there it goes. Boop, boop. And well, there we go. Of course, we can't quite have all the lights blink on and off all the time. So let's take a break. And when we come back, we'll figure out how to switch the lights on and off under our control using some fancy tools like this button here.